Imagine stepping onto a plane that could change the future of air travel forever. NASA's new airplane technology promises to slash fuel costs by 30% and save airlines tens of thousands of dollars on every flight. But why is NASA taking on this massive project, and what could this mean for the global airline industry? Today, we're diving into the groundbreaking innovations that could put American aviation back on top and transform the way we fly for good. To reduce as much as 30% less fuel consumption with better engines. On January 18, 2023, NASA Administrator Bill Nelson announced that NASA would design a revolutionary airplane by 2028. This airplane, through a simple innovation, will reduce travel costs by around 30 times. He mentioned that this plane would be so fuel efficient that it would save the American airline industry at least $45,000 in fuel per flight. And why is all this happening? It's because the government wants to re-establish its monopoly in the airline industry, and it knows that only NASA can help in this mission. Friends, it all began back in the 1970s, when the airline industry was dominated solely by Boeing, which not only elevated human travel, but also boosted the economy. However, once European countries noticed this, they started forming their own alliance to challenge Boeing's monopoly. This alliance included France, Spain, Germany, and Britain, who together introduced a strong competitor in the market called Airbus. On one side was Boeing, supported solely by the US government, while on the other side was Airbus, backed by 4 countries. Just 10 years after its entry, Airbus dethroned Boeing as the world's top airline company and struck at Boeing's biggest weakness, its ego. In retaliation, Boeing did what it usually does to competitors, giving a disproportionate response. Known for dividing the USSR in the early 90s, Boeing was not ready to let go of its rivalry with Russia and its neighboring countries, forming an organization called NATO. Understanding Boeing's historical mindset, when it learned that Europe had become the top player in the airline industry, it accused European governments of unfairly supporting Airbus. Europe retaliated with its own allegations against Boeing. Realizing both sides were incurring losses, they reached a mutual agreement in 1992, signing an agreement on large civil aircraft, with conditions like limiting subsidies. But did they follow these rules? Unfortunately, while Boeing was adhering to the agreement, Europe's Fantastic Four were still unfairly supporting Airbus. Feeling cheated, Boeing took the matter to the World Trade Organization, WTO, which eventually investigated and confirmed that European governments were indeed providing Airbus with interest-free loans. Enraged by this, Boeing sought NASA's help to create a new, fuel-efficient plane design capable of 30 times more mileage than any existing airplane. NASA and Boeing's new plane design is based on the Transonic Truss-Braced Wing concept, which will significantly reduce drag compared to today's normal planes. Typically, designing a plane involves a challenge with drag, which reduces fuel efficiency and increases the likelihood of crashes. This challenge dates back to early flying experiments which revealed that wings encounter drag affecting their lift. By studying this, German aviator Otto Lilienthal, known as the father of flight, found a way to plot the relationship between drag and lift. Later, American aviator Samuel Langley discovered that extending wing length could reduce drag, paving the way for the Wright brothers' first controlled flight on December 17, 1903. However, the Wright brothers' plane was a bare-bones structure, unsuitable for larger passenger planes. Just 17 years later, an aircraft based on their design, the Handley Page, crashed on takeoff due to excessive drag. Engineers realized that while lift should ideally be straight upward, air pressure on the wingtips bent them backward, creating induced drag. This drag can lead to accidents, as it did with the Handley Page plane. So, to reduce induced drag, engineers extended wing length and gave the front of the wing a teardrop shape, allowing most of the air to flow over it, thus reducing contact and parasitic drag. The result is that the longer and thinner the wings, the less drag, which is known as the aspect ratio. For optimal efficiency, the wing's length-to-width ratio must stay within a certain range. NASA has now designed a plane with an aspect ratio 1.5 times greater than normal. This is NASA and Boeing's plane design based on transonic cruise wings. The wings are long, thin, and light due to the use of carbon fiber, a strong yet lightweight material. Winglets are added at the tips, curved at an angle called the sweep angle, which will generate lift and reduce induced drag. NASA claims that these advanced wing designs will lower fuel consumption by at least 10%, and the addition of sustainable engines will further reduce fuel use by 20%. Altogether, this plane will use 30% less fuel than a typical plane, saving about $300 per kiloliter of fuel. For example, a 10-hour flight that would normally consume 150 kilometers of fuel will save around $45,000 compared to an Airbus flight. In simple terms, Airbus has been put in check for the time being. Additionally, NASA is working on a supersonic plane that can travel faster than sound without causing loud sonic booms. If you're interested in learning about this technology and how it's changing the world, click here to watch the complete video. If you learned something new, don't forget to like, subscribe to Flight Science and hit the bell so you don't miss any updates. See you next time.